Hello and welcome my dear students. So in this lecture series, I am going to solve some of the interesting and challenging numerical problem from the physics book Pathfinder. Let us start with the session. So in this arrangement, there are two blocks M1 and M2. They are connected with a spring whose stiffness is given as K number, and there is a friction between the floor and the block surface M1. Okay. So initially the lower block is held at rest. So M2 is initially at rest, keeping the spring relaxed and the vertical. Horizontal segment of the cord is straight. Find maximum possible speed of the block after the lower block is released. Once I release the lower block, so let us say the block M2 is being released and this is moved by distance x naught. If I say the M2 is moved downward by x naught distance, so M1 will move in this direction by the same x naught distance. Okay, so spring is elongated by the x naught number. Now, maximum speed, you are asked to calculate the maximum speed. So, maximum speed will be only obtained whenever the acceleration of the setup is 0. Acceleration is 0. That means in this situation, what is happening that M2G is acting downward. So, this is the force M2G, which is nothing but the tension in the string. Now, same tension is acting over here, T. Okay. And for this M1G, so there is a spring force is K into x naught in the opposite direction. And there is another friction force is there, that is equals to mu times m1g, mu times m1g. Now, if I say acceleration is equals to 0, which means the velocity of the block of system will be maximum. V will be maximum. I want to look for this situation, that is when the acceleration is 0. So, for this situation, if I do the force balance equation, so I can write kx naught plus mu times m1 into g, that is equals to tension, that is equals to nothing but m2g. Okay, so from that what I am getting, that value of x naught, the elongation, that is equals to m2 minus mu times m1 into g whole divided by k. That is the elongation when the block is under maximum speed. The elongation of spring. So once I got this number, now I can do the energy balance equation to get the answer of the maximum velocity. So for energy balance, what I'm going to write is that here work is being done by the friction, only the friction force is there. So work done by friction, that should be equals to K final plus U final minus K initial minus U initial. So if I say this is our reference line, so from this reference line, what I can say, that work done by friction is how much? Minus times mu mg minus time mu m1g into x naught. Into x naught is the elongation. So x naught is the distance traveled by the friction force. So equals to final kinetic energy. Final kinetic energy is the setup when the both m1 and m2 are moving to the same speed, that is v. That way I want to calculate half into m1 plus m2 into v square. That is the final kinetic energy. What is the U final? So U final is the elongation, and there is a drop in the potential energy also. Okay. So U final is what? That is the spring is elongated by the half k x naught square. Half k x naught square is the elongation of the spring. And there is a drop in potential energy of M2G. M2G is being dropped by distance x naught. So that is equals to minus M2G into x naught. M2G into x naught. That is the final. So this number is basically the U final. Final potential energy. And what is initial kinetic energy? Initial kinetic energy is released. That means it is 0. Initial kinetic energy is 0. Initial potential energy, that is also 0. That is also 0 because spring is under relaxed condition. So this is the energy balance equation. So if I solve this equation, that gives the value of V. Okay. So once I rearrange this, so in order to rearrange, so I want to calculate the velocity V. So take all the other quantity in the one side, then further simplify. So that means I am getting that for this equation, that is M2G into x naught, M2G into x naught minus mu times M1G into x naught, minus half k x naught square, minus half k x naught square. That number will give the value of half mv square, that is half into m1 plus m2 into v square. Okay. So if I simplify this to calculate the velocity v. So finally, I am getting the answer. I am only writing the answer. So you just check whether you are getting this or not. So v should be equals to m2 minus mu times m1 whole divided by multiplied by g whole divided by root of a times m1 plus m. A times m1 plus m2. So that is the answer. Okay. So just check it whether you are getting this answer or not, and please write me in the comment box if you have any difficulty in understanding this. Okay. So thanks. That's all. So if you like this, please subscribe my channel